Let's take another look at, let's take a look at another example, rather. In this case, co-integration and pairs trading. So I want to identify a pair of stocks, in this case, that I believe to be co-integrated. Co-integration implies, as I've written on the slide, long-run co-movement between the stocks. In order to identify it, I will use the method of Engel and Granger. There are other methods around, like the Johansen method, but the Engel and Granger method is simple to implement and intuitively easy to understand. We will use the co-integration information to identify a pair that we might want to trade, and then we will see whether we can actually build a strategy around that. Let me clear my workspace once more. Close all of my figures. So, I have some stocks that I've downloaded using the data feed toolbox from the Yahoo site, and I will load them up into my data here. So I've saved them in a file. So evaluate selection P. There they are. They are 34 stocks taken from the portfolio of stocks that together make up the FTSE 100 index. So one of the things I want to do is cycle over these and try to identify co-integrated pairs. So let's have a look at that. I'm going to run this function right here. I will return my co-integration matrix, CMAT, and we look at that using the image SC heatmap command. And I'll put a color bar. So there we are. This gives us information about how co-integrated certain stocks are. In this particular example, the colors are reversed, so blue indicates a likely co-integrated pair, red, unlikely. The more blue it is, the more likely it is. Using this information, we can start to zoom in on particular pairs that we think are useful. So for example, let's remove all of the pairs where the value here is greater than -5. And let's take another look at the image. Okay, so these are the most co-integrated pairs that we have left. From this, I'm going to just pick one at random, but in principle you might want to try and trade all of them as a portfolio. For the purposes of this example, we will just look at one. I'm going to pick pair 9 with pair 23. If we want to see what they are, we can have a look at the stocks. And 9 against 23 gives me sometimes surprising results, I must say. So Carnival against Reed Elsevier. Let's have a look at them. Nine and 23. One thing we notice straight away is that they're on quite different scales. They're both trending, so perhaps there's some information there that we can use. I will try and put them on a better scale by looking at the logarithms of the data rather than the raw data itself. So log of 9 and log of 23. You can see much more clearly that there is definitely some correlation between these. There is some mismatch in the first 100 or 2 points, but then after that they move together quite nicely. What we don't know at this stage is if that movement is enough to be able to generate a successful pairs trade or not. So we can have a look and see. I will run a script here. I'll close some of these. Close this, and that. My co-integration script. Let's see how we go. I need to make some data. That was a mistake. So let's see. X will be my data 1 and 2. In fact, what we'll do here, we will try some in and out of sample testing. So I will make some data which is only the first 800 points, and I'll call that test data. So test data takes only the first 800 days worth of data for columns 9 and 23 from my portfolio. And my X and Y data will be the first two columns of that. I'll now run my co-integration script against X and Y. This takes just a few seconds. So what it's actually doing here is it's using the co-integrated information that we have. It's doing a simple regression between X and Y to identify weights in which to trade them, and then it's trading them based on that. I specify an update rate of once a week or once every so often to update my regression. So here we have a positive P&L line. Nothing very much for the first couple of 100 points again, but we might have expected that, where there's a lot of noise in the data up front. We do have something else to check though, because we have built an in-sample model. So let's see how the model performs on our out-of-sample data. I will get my best Sharps ratio. And this time I will use all of the data, not simply the first 800 points. Let's have a look and see how that does. So the Sharps ratio that we get from that is 1.8, very high. So we would be pretty happy with that if we were actually building this model. Let's have a look at what the P&L looks like. So we tested the model, or built the model, on the first 800 data points, which is up to 2000. Everything post 800 is truly out of sample, and we see the model continues to perform well for over a year out of sample, earning money as it goes. So this is a relatively successful test, showing that the co-integrated pair do indeed move closely enough together to allow us to trade them. We might be interested to see what sort of positions we were trading, so we could have a look at them. I have had my model return them. Green is the position of one and blue of the other. You can see that we do trade quite a lot over the period of nearly 4 years or so, and we do vary our positions, but not outrageously so. Sometimes we hold our positions for quite a long time, which is what we would hope to see. If we decided to trade all of the co-integrated pairs that we have, then we would run into other problems of bookkeeping that we would need to worry about. This is something that we won't think about too much for this example.